Hello, so today we are going to do this problem, which is today's Leetcode daily challenge, minimum number of moves to seat everyone. So basically this problem, we have n seats, we have n students in a room, and we are given the seat array, so the available seats, where each position basically here, seat, the value in that position is the ith seat. And then we are given students where that's the value is the position of that student. And what we can do is any number of we can do some this operation any number of times. The operation can be either increasing the position of the ith student by one or decreasing it. So pretty straightforward. Now, what do we mean by increasing or decreasing it? So, for example, for the student 0, if we increase the position, then this becomes 1. If we decrease it, it becomes 0. Sorry, if we increase it, it becomes 3. If we decrease it, it becomes 1. Same thing here. Increase it, position, then they will be in seats 5. If we decrease it, they will be on seat 3. Now, the goal of the problem is the minimum number of moves we can make so that all students are seated in the available seats, but also no two students share the same seats. Like we can't have this one be 3, so we increment and then decrement this one to 3. Then they will both be on seat 3, and that's not allowed. Okay, so that's the idea. Now, how do we do it? Well, the first thing to know is that the positions here need to match this one. You can't we can't keep this student at position 2 because then that position 2, that seat 2 doesn't exist, right? So what we really want to do, if we take a look at some examples here, let's take a look at so if we take a look at this here, right, for seats and for students, what should we do? Well, for each student, we want to get them to the closest seat to each one of them, right? Because that will mean we will need to do the minimum number of operations to get that student in a seat, right? That just makes sense. So, for example, for this two, it makes sense to make it to go to the closest one, either 1 or a 3. The closest one is going to be, of course, 1. So we decrement. So now the number of operation is 1. For this one, for this student, it's good to make them go to 3. So we decrement. So now we have 2. For this one, for this student 7, it makes sense to put them in seat 5. That's the closest. So we decrement by 2. So that's 4. And that's done. Now they are all seated in the seats, right? Now, one thing you may have noticed is when we were at like this, for 2, even though the distance between it and 3 and between it and 1 is in both the direction it's 1, it makes more sense to put it in 1 so that we leave this 3 for 4, right? Now, how do we do that? Well, we can just sort both arrays. That way, we handle the smallest elements first, because that's exactly what we want to do here. We want to give 2 the smallest element of seats so that for the next element, the bigger element in the student, they get to the next one, right? And so what we want to do is first sort. So what we can do, for example, in this example here, we just sort this so that it's 1, 3, 5, and then sort this so that it's 2, 4, 7. Then we can just see how many operations it will take us to get this one to this one. We know it's the closest to it because we sorted, so it's going to be as close as possible. We can either we'd have to take it or leave it, but we can't leave it because the number of seats are exactly as the number of students, right? So they have to take this one, and so the difference is going to be we just take the difference. What's the difference? It's 1. Between 3 and 4, we have to decrement 4 by 1, so the difference is 1. Between 5 and 7, we have decrement 7 by 2. And so we just take the sum that gives us 4. That's what we need. Okay. So that's the approach we can take here, is basically just sort both. That way each one is as close as possible to the most optimal seat. See how many operations we need to move the student to that same seat in the same position, and take the sum, right? So to do that, we need first to sort seats. We need students sorted as well. And we need to take the sum of the difference. So we just say sum. Uh, of course, we need absolute value, because what if this was like 4 and this was maybe 5, right? So this one is bigger. So in that case, we still want to get a positive value, because we can do any direction. We can do +1 or -1 move, right? And so we just do absolute value of seats at position I minus students at position I, and we go through all positions. And this should work because we know they both have the same length. Okay, so we do that, we return it. That should be all we need to do. Come on, this. It gets accepted. Okay, now in terms of time complexity, this is O of n log n, n being the length of seats. This is O of m log m, m being the length of students. And since they are both close, they are both equal, we can just say it's O of n log n here, O of n log n here. So overall, it's O of 2n log n, so almost pretty much O of 2n log n. And by the way, that's Leetcode here has a new nice feature where uh, it analyzes the complexity for you, and it told us that it's O of n log n. Um, yeah, so that's pretty much it for today's problem. Pretty easy problem today. Thanks for watching, and see you on the next one tomorrow. Bye.